Hi everyone. In this video, we will learn about a tendency of resolving of the objects by the human eye. This is a very interesting phenomenon. Many times it is observed that when a long distance object like for example, a four-wheeler is being viewed as in this figure, and a person is trying to view a four-wheeler very far away, but it seems the two headlights seems to be as if it is a single headlight when the vehicle is quite far away. The reason is the person is not able to resolve the two headlights separately. That is what is called the resolving tendency of the human eye. Is it a defect of the human eye? No, it is not a defect of the human eye. Rather, it is the diffraction nature of light that has caused the image formation of the two headlights so that they will overlap. The images are overlapping on each other and it seems as if it becomes a single headlight. The same person will be able to view the two headlights separately when the vehicle comes nearby. That means there is a minimum distance required so that the person can view the two headlights separately as a distinct object. This is what is the tendency to resolve the objects uh, by the human eye. The reason being the diffraction nature of light. So in this video, we will learn about how to calculate the minimum distance required of the objects so that it can be viewed as separate objects. For example, when the two distant stars are being viewed on the sky, maybe we are able to see a single image. That means we think as if we are looking at a single star, but the image is actually formed by the overlapping image of the multiple stars. It may be two stars or more. So the human eye is not capable of forming or you can say resolving the images of the two or more stars separately. So that is because of the diffraction nature of light. So that is what we are trying to understand now. So in the case of stars or long distance object, many times we used to say that it is the minimum angular separation required between the two stars. Let us try to calculate that minimum angular separation required between the two stars so that it can be resolved and it can be viewed as distinct objects. So what we are trying to say now is that the two distinct stars forming the diffraction pattern and therefore their images are overlapping on each other on the screen. Screen means to say like a retina of the human eye which acts as a screen, and therefore the images cannot be distinguished. So we will try to draw the situation by the overlapping situation of the two images, and we will try to arrive at a critical stage, critical situation when the two images, that is the overlapping images, are just resolved. So let us try to draw the situation first. So what we try to say here is that the image that is formed by a single object, for example, let us take a star forming an image. The reason is the diffraction nature of light. What is diffraction nature of light? Is that when it forms the image of a star, for example, this is a star long distant away, somewhere in the sky, and it is being viewed by the human eye to form the image on the retina, which is acting as a screen. So the reason is when the light is coming long distance, it has to pass through various points like sharp edges and corners, and definitely it has to pass through the lens, human eye lens. Human eye lens acts as an aperture. So when it is passing through that aperture, it will diffract and it will form an image which will never be a sharp image. It will be an image such that it is having a central bright maxima like this, and subsequent to it, there will be other smaller maxima like this. That is how we will never expect an image formation to be a sharp image. It will be always an image having a central maxima. This is what is central maxima, which is the brightest and the sharpest central maxima, and surrounding to it the secondary maxima, which are present even though they are not bright. Now here the situation is something like this. The central maxima that is formed, it is having a width. This is the width of the central maxima. So that is why we want to say here that diffraction of light is because of diffraction of light, the image, that is the central maxima that is formed, is not a point size image. It is having a width. So the width is the end of the width is called as their minima position. This is a minima, and here also it is a minima, which is what is represented in the Young's single slit experiment also. That is a central bright maxima and its subsequent minima. Now this is a single star forming the image, the star being very long distance away. What will happen if we will have one more star present nearby to it? It will have the similar type of image formation, having a central maxima surrounded within the secondary maxima, and now the both images will overlap. Let us try to draw the two overlapping images, and then we can conclude that those overlapping images, when they can be said to be just resolved, fully resolved, or not resolved at all. Let us try to draw that situation. So drawing that situation of fully resolved. When can we say the image formation, that is the overlapping images of the two objects, let us say the two stars, they are fully resolved. So if we try to draw those, let us draw one by one. For example, the central maxima of one of the object, let us say star 1. Secondary maxima also I am trying to draw. This is for object 1, we can say star 1. Similarly, another star forming the image, well resolved image, or we can say fully resolved. So it can have a situation when its own peak, that is the image of the second object, the peak of it is far away, something like this. This is for object 2, or you can say star 2. What we can observe here is that the distance between their peaks is well separated, and technically we will say that like this, that the peak of the second object is not lying just above the minima of the first object, rather it is quite far apart. That is, the peak or the maxima of the second object is far away. This is the distance of separation from the minima of the first image from the maxima of the second image. So because of this distance, this is called to be fully resolved, and the images can be easily viewed as a distinct image. We can have a situation of non-resolved. We can draw that situation in such a way. If I draw that non-resolved images. Similarly, if I try to draw here, so this is for object 1, and overlapping to it the image of the object 2, but now it is very close, that is the peak or the central maxima of the image of the second one is very close to it, something like this. It is, the peaks are so close. How do we say that it is not resolved is by this fact that the peak of the image of the second object is lying within the minima. This is the minima position of the image of the first object, and the peak is lying within it. So therefore the images cannot be resolved. We cannot see them as a distinct image. So that is why we will say it is a non-resolved situation. Let us take a just resolved situation. In the case of just resolved, how do we draw that? That is, the image is just resolved. Now here we are going to derive or arrive at a critical situation at which we will say the images are just resolved, and beyond that we will always have a resolved situation. So similarly, let us try to draw the images of the two objects. central maxima. This one, central maxima, it is having its own minima. And now let us draw the overlapping the image of the second object, which, which is said to be just resolved situation when the peak will lie just above the first minima of the image of the first object. So this is how we will say, if we draw it something like this. So we will say this is a critical situation of just resolved situation when the peak of the image of the second object just lie above the first minima of the image of the first object here. So this becomes a required condition. We can write this required condition by using the Young's single slit experiment result, in which we have said that the angular separation required between the first maxima, that is the central maxima, with the first minima of the object. It is given by the formula sine theta, where theta is the angular separation between the object, is equal to lambda by d. Lambda is the wavelength of the light which with the objects are being viewed, and d is the aperture size. Aperture. You can say aperture diameter. For example, if we are viewing it from our eyes, we will say it is the diameter of the eye, or you can say diameter of the lens of the eye. So using the result of the first minima position of the Young's single slit experiment, we are able to write this expression where theta is the angular separation. Angular separation between the central maxima and the first minima. So based on this, applying the condition that if it is a circular aperture, there is a small modification required for a circular aperture. Circular aperture like lenses or the human eye, for which there is a multiplication factor used. We will say 1.22 getting multiplied with it. So I will write it as sin theta is equal to 1.22 into lambda by d. So this is how the angular separation formula we derived, where theta represents the angular separation between the two just to be resolved objects. We can use this formula and we can arrive at the minimum angular separation required between the two objects to be viewed them as just resolved. Now once we have the minimum angular separation that is required between the two objects as given by the formula, that is sin theta is equal to 1.22 into lambda by t, that we have just now understood. Based on this minimum angular separation between the two objects, now we can find out the maximum distance up to which the two objects can be just resolved. So let us go back to the figure that we have seen earlier, that is the two headlights. Think of the two headlights. They are separated with respect to each other by a distance of small d. And if you want to view them as a distinct object by the eyes at a distance of, let us say this distance as L, what should be this maximum distance up to which we can resolve these two headlights or the two objects as a separate distant objects? So using the formula of theta, that is theta minimum required, that is the angular separation of the two objects. If I mark that angle theta here, that is the angle subtended by the two headlights here, or we can say any two objects that has to be resolved. Using geometry here, we can easily write that theta being very small, I can write as theta is equal to d by L, where L is the maximum distance up to which the two objects can be just resolved. So from this equation of geometry, we can write the formula that is L, that is the maximum distance, is nothing but it is d by theta, where theta should be in radians. So this becomes a formula which we have arrived at by applying the method of diffraction effect of the light And we have understood it by the application of the Young single slit experiment result, in which we have applied the angular separation theta that is required, minimum angular separation to be required between the two distinct objects, so as to view them or their images as distinct images by the human eye. So from here we are able to calculate the maximum distance up to which we can resolve the two objects as a separate distinct objects. Hope this video is clear to everybody and everybody has enjoyed this video. Thanks for watching this video.